Okay, welcome everybody. Very happy to see you here and that you came to Delft for this mission, the shared mission, which I will elaborate a little bit on during the presentation. And I think open sky is extremely important for us, so I think it's very fitting that it's finally in Delft and that you took the effort to travel here. That's really appreciated. So Junzi asked me to give a keynote speech, and he left it relatively open for me what I wanted to discuss. But Junzi and I, as he mentioned, we share several passions, so automatically I think it fits very well in the theme that Junzi had in mind for this edition of the conference, and otherwise he will probably correct me during the presentation, right Junzi? So the topic is about open data and ATM science. When I, in 2013, started the chair, one of the themes that I wanted to start is the foundation theme that I called it. And the inspiration for that was a figure that we call the spiderweb figure. And the idea behind this explains sort of, I think, part of the motivation of why at least we're doing, and hopefully you recognize some of it in what you're doing, the work as we do it. So what you see here is the current world in air traffic management. You can clearly recognize this. This is how things work now. Then the idea is that you, if you read a paper of a conference, and as reviewer or editor, you will come across many of these papers. And you often read about some new concept, let's call it A, that is very promising, it's investigated and it's evaluated, metrics are defined, models are made, simulations are run, maybe even flight tests, and surprise, surprise, at the end of the paper, you rarely read that it's not feasible. Most of the times it's actually feasible. So we should all do A then, right? But you don't know if it's better, of course. But if you're lucky, it has a comparison with the baseline, with today, and it even states concept A is much better than we do things today. So we should all do A. But then the day goes on, you come across another paper that says B, completely different concept, non-compatible, uses different metrics, different variables, different simulations, different scenarios, and surprise, surprise, it's feasible and it's better than today, but not compatible with A. And those are not the only ones. There are many more papers, and they're all proposing a concept as the solution to all the problems you have in aerospace. Well, imagine now that you are an authority, or you are a navigation service provider, or you are to write a long-term vision for the development of a supplier of ATM equipment, right? And they ask you, well, what would we have after 10, 20 years, because we want to focus our long-term investment in that direction. And you think, well, we should ask the scientists. So you go to the conferences that we all attend, and you check out the papers, and you'll find this. So the question might be, do we need to automate things in the future, or will it still be human-centered automation? You will find papers arguing either. They will be better, feasible. Will we have UTM? Will we have a lot of UAVs in urban airspace? Will they still need to file a flight plan, or will they do everything tactically, emerging behavior, or will it be controlled? You'll find papers on both. Will we have super sectors or one sector? You'll find papers on both. So it's impossible. So I think we have to look in our hearts as scientists. Of course, we think this is all extremely nice. Wow, a new method, new concept. We think it's interesting. We're surprised it's well done. But for the people that want to use our results, it's a nightmare. Because they are stuck. They don't know what to do. So I thought, well, what is really what you could do about it? Well, I'm not the first one to think of it, and probably many have. There are many examples to be found. For instance, there was the EOVCM. I think by Eurocontrol, that's where the E stands for, if it's not for European. But, and it's the, I forget the O, but validation concept, M something. It's at least one of the many attempts to harmonize research to deliver results that we can actually use. And you see a lot of, it's a bit blurry, but a lot of phases you have to go through that have templates for documents that you should produce that will help the users use your results. Well, this was not adopted. Personally, I also did not adopt it, and maybe many persons did adopt it for the same reasons. It's extremely tight. It's like a straitjacket. It forces you to do things according to this metric, this document. And general researchers are typically, and if I look at the room, I think it's true, young, creative, ambitious people that want freedom to explore the avenue to the future, right? Doesn't really fit well with the approach of having tight metrics that have to force you in a fixed line according to some committee that came up with it. So I think this is not forcing things top-down is not the best way to do it. Well, the opposite of top-down, of course, is bottom-up. So one of the things so what could you do bottom-up? That you have to provide people with the things they need. In a lot of papers, you see that people made their own simulation. That often takes a lot of time. Debugging software is something that's really time-consuming, and models do what you put in there, but if it's really right. So one of the things that I thought, what researchers really need is often traffic simulation, traffic generator. Whether you're doing human in the loop, you need traffic generated, or fast time simulations, whether you do urban or airline, airport, we all need constant traffic simulations. That's a lot of work. So why not make an open ATM simulator? We call it Blue Sky, because originally it was aimed at blue sky research, that is able to do all these different kind of researches, but on the same platform. So you can do urban air, and you see here the urban simulations. Andres is an audience, he worked a lot on this. You see here an alternative for the Dutch airspace. We see here the emerging patterns of self-separating vehicles. We see some airports, some capacity things, and of course a lot of metrics that are built in there to make these plots and try to derive the relations. So, of course, also with simulators, people really like to build their own as well. So you never know whether it's going to be adopted. It's often better or simpler to make your own because that one you understand. So the trick is, of course, to make it adoptable by person. How do you tempt people to use a program that they didn't make themselves? Well, first of all, it has to be fully license free because as soon as you go to the legal department, that's the best way to stop any project. So that's what you should avoid. And also it should be financially free, so you don't have budget constraints. It should be easy to use. That's always a challenge. Everybody tries that. Everybody thinks that it works according to their logic. Hence it makes sense, but okay. And it has to be also fully open and transparent and easy to contribute. So this resulted in many choices, one of them being that we programmed everything in Python. That's a language that has a community, and you know it now, but when we started it, it was just many of several other languages. Julia was still on the table. People were using R a lot. So, but we chose Python, and now it's been used a lot. And we did a lot of other things to make it adoptable by the community. Extreme open data, open source. So also aircraft performance models, navigation data, you can all buy them from Jeppesen or from Eurocontrol. But we wanted not to use it. We wanted to use only public data in a rigorous way. We also made, inside Blue Sky, and that's also thanks to Joost Ellerbroek, he's not in the room, but Joost Ellerbroek quickly joined the team and later Junzi, and now we have a lot of students and people working on it worldwide. I know that also Xavier, and there are a lot of people that contributed to the Blue Sky in the meantime. But Joost made a plugin structure which allows you to add your own programs without knowing everything of Blue Sky. You can basically control Blue Sky as you would as a user. If you read the user manual on GitHub, you can control it as a user from your plugin, and you can access any data, and that's the interface. You don't need to keep to any. You're completely free to make your own preferred style of code, do your own things, make your own data files. It's completely in the spirit of not forcing people into a straitjacket. We wanted to keep it as open and simple as possible. And there are a lot of plugin examples because the best way to make a program is to copy one that looks like it and then change it, right? So that's also included. But data. One of the first things we ran into, of course, was that we needed aircraft performance models. And those are the most sensitive data. If you ask Boeing, what is the performance of your newest aircraft, they will probably not immediately send you some data on a stick or on a file link. Same with Airbus, and especially they're looking at each other. So we all know BADA, of course, was a result for the same question, right? BADA made by Eurocontrol, aircraft performance data made by Eurocontrol. BADA 3 was freely accessible to everybody and was hugely adopted by the research community for many years. Unfortunately, to further improve and develop BADA, they needed better data, which in the end led to licensing. So also BADA is now subject to licenses, I think up to 3.10 or 3.12 you can use it. Newer versions are subject to licensing. So what else to do? The idea of having all these aircraft out there transmitting ADS-B data is basically giving away their performance in a way. Maybe for one individual aircraft you have too many unknowns to solve the equations, but if you look at all the aircraft, you know the weight range, the mass range that they have, So looking at the big data approach for performance, you should be able to guess the relation between the other parameters and the weight. The weight is always the big unknown in ATM of the aircraft, because that's the fuel plan and the payload. So we came up with the idea to make open aircraft performance data. And this was a lot of work, clearly, because it required a big data approach, a lot of new algorithms, because constantly you have basically not enough data, and could we still crack down to get actually BADA quality models using only open data, fully license-free. So for that we hired a very smart PhD student to be able to solve this for us, and that's Yoon Soon. And he was indeed able to do that and much more, as we get to see later. He did this approach, he came up with very new algorithms, borrowed some algorithms, adapted them, and was really maybe even more enthusiastic about this topic than I am. So I'm really, and he is I think OpenAP has now a name on its own. We wanted this for Blue Sky, but you can also use it separately, Open Aircraft Performance Model, in any program that you want for analysis of aircraft performance and emissions. Because that's the latest edition, we have more and more emission data on it as well. And that's the link with sustainability that Henry also mentioned. This is also in the same spirit as Blue Sky, fully license-free. It's on GitHub, you can download it and use it for any purpose. You can modify it, we don't need to know. You can do anything with it that you want, like with Blue Sky. To do this work, of course, he gathered a lot of ADS-B data. We put our own antenna on the roof. We also used other sources, and this is where OpenSky comes into the picture. We, of course, supply our data then also to OpenSky, and we found this trove of data at OpenSky, so this was really like a sort of short circuit of data. Suddenly we had a lot of data, and this really accelerated our development in this area. Yoon needed to decode our data, and so we put on the roof a device. It's a very simple ADS-B antenna with some servers under the roof here, and we call this facility SIL. It's not for, what is it, Signal Intercept Laboratory or something. It stands actually from SIL de Strandjutter, which is a old Dutch television series, which sort of loosely translates as Sylvain the Beachcomber. Getting things for free which are out there was the sort of inspiration. So that's the SIL facility. But our SIL is actually another person at Yoon Soon again. Because he was the one that actually set this up for us, made the server, made a database, and makes it freely accessible. Also the raw data you can access, and there are packages that you can get, and you see some examples here of the data as it was published. And this was also how we partnered with OpenSky and several other partners, supplying the data, getting the data, and feeding the data. So, of course, Yoon was by then much more than a PhD, because we were very happy that he decided to stay at Delft, and he's still working as an assistant professor in my chair, doing a lot of good work. So this we had now. So, but to use this data, of course, you also translate it. And in the same spirit, Yoon continued on and said, well, the decoder that I make, Pi Mode S, I'm also going to publish this to use for everybody else to do the same work elsewhere. And the Pi Mode S was actually so famous that I had students in my first year programming course coming to me, yeah, I want to do a project, because they could do some project for points there, that I'm going to gather ADS-B data, and I found this very nice tool, Pi Mode S, from a guy named Yoon Soon. Have you ever heard of that? Well, we had. So it was really nice to see the full circle back, that people were able to find him on the web. And I think he also this helped in creating his name. And he published also a book on it that's now freely available as well. You can download the PDF, the 1090 megahertz riddle on decoding ADS-B, and I think even a bit more than ADS-B, the Mode S signals. So that, of course, are a lot of efforts, and you see one name coming up a lot, and that makes us very happy. And I hope that the mission of OpenSky is indeed along our lines. I have the impression, I think it's a nice cooperation. We are very happy with the cooperation. But of course, you also have to think, what is the status now? Where are we? And so we started off, this was our journey. So an open air traffic simulator with open data, open air performance data, needed the traffic data, etc. Well, I'm happy to see that at least we're not alone. This community is here, and you could see last week you probably also got the same. You see how much data was no longer used by Eurocontrol, but actually by OpenSky. And before this we had Eurocontrol data, but that also the data got more licensed. And you see that the adoption by OpenSky recognized, this was actually distributed by Eurocontrol, showed that the adoption of OpenSky is going really in the right direction. So I think it's sort of taking over this world. Then, looking back at our original goal, are we there then? Is it now possible to compare all these concepts A till H? To be honest, I think a lot of good steps are made, but I don't think we're there just yet. So we have a lot of coffee breaks today. There we have an opportunity to discuss things with each other. So I would like to ask you, so if you look at today's research and you want to compare two concepts, you want to reproduce the results, you want to understand what's really going on, can you do it? And what else, next to the open sky data and the efforts that are out there, what else should we do to make that happen, to really reach the original goal? So what do we need to make ATM research fully transparent, repeatable, and comparable? And of course, without forcing people into a straitjacket, because that's the trick. We all want to leave people free to explore their own ideas and let their creativity flow. So, I wish you a good conference, an inspirational conference. I hope you see a lot of examples of studies that are repeatable and comparable. And otherwise, please keep this in the back of your mind for discussion during the coffee breaks. And I hope you meet interesting people, get inspired, and if you haven't already, join us on this mission to improve the world with ATM Science. Thank you very much.